Here we are analyzing Reagents Part 1 exam, which was conducted on our online test series. So please don't watch this video if you didn't attempt the exam. So please go and attempt it, then only watch this video analysis to get best benefits from it. Okay, right. Now just look at the given problem. The major product X in the following reaction is. Just look at the given reactant. We have given with allylic epoxide, and here we have alcohol and titanium tetraisopropoxide. We know that alcohol here can act as nucleophile and which going to open the epoxide from two possible ways. Okay, so which is the correct possible way? And another point we can just note that epoxide is with thick lines. It means epoxide is above the plane of the molecule. Okay, right. So the nucleophilic attack should be takes place from the bottom side. Okay, so we can consider epoxide opening is SN2 type. That's why opposite attack should be there to open that epoxide. Okay, right. There is a question where the nucleophile should open the epoxide. It is determined by titanium tetraisopropoxide because the titanium can act as chelating agent. Okay, here titanium acts as chelating agent and which chelates with lone pair of electrons on epoxy oxygen and hydroxy oxygen. Okay, now just try to draw the chelation here. Okay, right, and I'm just taking the epoxide on the plane. When we do that, so the group should move above the plane. Okay, that is hydroxy or CH2OH group should be above the plane, and in that case I'm just drawing OH here. Okay, right, and then titanium interacting with the lone pair of electrons on epoxy oxygen and hydroxy oxygen. So here is the ligands of titanium. Okay, so due to this chelation, and here other side we have 5-membered ring. Okay, so due to this chelation, a nucleophile is only having one way to open this epoxide, that is from here only. The nucleophile cannot open from this side because due to the chelation, steric repulsions can be seen. Okay, that's why nucleophile always open this epoxide from this 5-membered ring. Okay, that means the epoxide opening takes place from here. Okay, and nucleophilic attack here. That's why OR. So OR should be from the below the plane. Okay, whenever attacking takes place, OH will be above the plane and the nucleophile, incoming nucleophile should be from the below the plane. Okay, so that's why second option is the correct answer. What is the major key point here? The chelating agent, titanium. Okay, titanium complex. So just look at it. Next question. The major product X and Y in the following reaction. Just look at, we have taken another allylic epoxide. So we have a red aluminum reagent and DIBAL reagents. Okay, here what is the correct combination of products in the given 4 options? Okay, right. First thing, do you know the structure of red aluminum? Here, just write. So red aluminum contains 2 hydrides, or simply here we can say 2 hydrogens, CH3 here, and again, sorry, here OCH3. So this is the structure. Here is the board. Okay, this is the structure of red aluminum. I now just try to check the structure of dibal. So dibal only contains one hydrogen. Okay, so diisobutyl aluminum hydride. It is considered as dibal. It is having only one hydrogen and which can be cleaved as H minus. Okay, right. Now try to check the mechanism which involves in reduction with dibal. Okay, so how reduction or the epoxide opening takes place with red aluminum. Okay, right. Now just draw the epoxide here. Okay, and so this is the hydroxy and this hydroxy attack on red aluminum and one of the hydride eliminates from it and this hydride just react with this H plus which comes out from this hydroxy group and cleave as H2 gas. Okay, so here the connection with red aluminum can be observed. Okay, so it is hydrogen and this is the rest of the pot of red aluminum. Now you can see that the hydride can attack from this side because the interaction. Okay, so intramolecular, okay, just write down intramolecular hydride delivery takes place. That's why epoxide opens here, right? And just draw the next part of it, OBN, right? So whenever epoxide opening takes place, you can see 1, 2, and 3. So just check the options here. And always this hydride attack should also takes place from the below side because epoxide is given as above the plane of it. Okay, so stereochemistry very important. Yeah, so whenever hydride attack from bottom side here, then you can see two hydroxy groups at 1 and 3 position. Just check first and second option of X. These two are wrong because two hydroxy groups are on 1, 2 position. Two hydroxy groups must be 1, 3 position. Okay, so 1, 2, and 3. And as we said, the epoxide hydroxy group should be with thick line because epoxide is above the plane and this attack is also SN2 type. So here hydroxy group must be above the plane and here the hydrogen must, that means the hydride which attack should be backside of the plane. So no need to just show it. Okay, right. So on reduction or on epoxide opening with red aluminum should give as X, which is given in third option. Now just check a dibal. So how dibal can react? Here just draw the reactant. Okay, so here the next part and here just to say hydroxy group which is interacting with that aluminum of dibal. So here we have isobutyl group. Okay, and so the aluminum interact with this epoxy oxygen. What is the difference you can observe here from red aluminum and dibal? In dibal only one hydrogen is there, that's why. So one hydrogen should be eliminated as H2. So aluminum interacting with both the oxygens of the reactant by that dibal aluminum. Whereas in red aluminum only one hydride is eliminated whenever it is interacting with allylic hydroxy oxygen. Now the hydride, another or remaining hydride just delivering intramolecularly to open this epoxide. Whereas with dibal, extra dibal should work here. Okay, so just write here isobutyl aluminum hydride. So this hydride should attack here to open this epoxide because this dibal cannot attack from this side because of steric repulsions and only the attack should take place from here to open this epoxide. In this case you can see 1 and 2. So two hydroxy groups must be at 1, 2 positions only, and due to the presence of epoxy group on above the plane, then the opening hydroxy group, epoxy hydroxy group should be above the plane. You can see 1, 2 and epoxy hydroxy group on above the plane. So Y product comes from that dibol-benzene. So option 3 is the correct answer. And what is the main important point here we need to note? That is, with red aluminum, intramolecular hydride delivery takes place, whereas with dibol, the intermolecular, okay, intermolecular hydride delivery takes place to open that epoxide or lilic epoxide. Okay, right.